Hello students, today I'll teach you all to find the sum of n terms of an arithmetic progression. Okay, let's do it. Let first term be A, common difference equal to D, number of terms equal to n. Okay, then we have to find the sum of all the n terms. Okay, so a plus d, a plus twice d, a plus thrice d, and so on, comma, a plus n minus 2d, comma, a plus n minus 1d are in AP. Okay, now we will find the sum of all these terms. This is the last term over here. I'm writing, look, this is our first term, second term, third term, fourth term. This is nth term, that is the last term. Okay, this is the second last term. Okay, now we will find the sum of all these terms and we will get a formula. Okay, let S equal to A plus D plus A plus 2D plus I'm writing over here a plus n minus 3d plus a plus n minus twice d and a plus n minus 1d. Okay, now what we have to do? We have to add up, but there is some procedure for it. You know that if I add 1 to 10, like 1 plus 2 plus 3 plus 4 till up to 10, its sum will be equal to the sum of 10 plus 9 plus 8 plus till 3 to 1. Is it clear? Now I am going to add this in reverse order. So its sum will be also equal to S. So I am writing it S equal to, see, I am writing the last term over here, a plus n minus 1 times d. Then second last term I am writing a plus n minus twice d. I am writing the third last term, that is a plus n minus 3 times d. Okay, plus I am writing. Then I am writing this a plus 2d, because its order is reversed. Then I am writing a plus d, and in the last I am writing the first term. That means this is the first, second, third, and so on. This is the last, second last, third last. I'll just reverse the order of adding it. Okay, so I've written last term, second last term, third last term, and over here see the first term, the second term, and the third term. Now I am going to add up. When I add, what will I get? I'll get S plus S equal to twice S. Over here I am going to add this first term with this last term, the second term with this last second term, third term with this last third term. Okay, over here I am adding A to this term, last term, over here with this, and this term with this. Now let us see what we will get. Okay, so when I add A with this number, what I get? A plus A equal to twice A times D. Okay. Now look, when I'm adding A plus D to this term, what I'm getting? A plus A twice A. Now we have 1D over here and we have N minus 2 times D. This means when I'm going to add, what I'll get like this, N minus 2D plus D. That means I have 1 over here. When I take D common, it is 1 plus N minus 2D. When I open the bracket, inside the bracket, I'll get N minus 1 times D. Is it clear? So I'm writing over here as twice A N minus 1 times D. Okay. Next. Over here, what I am going to write, I am adding this over here. So what I get? Twice A plus N minus 1 times D. Got it clear? Plus dot dot dot. Now look over here. This term I am adding with this. A plus A equal to twice A. And 2D plus this much will become N minus 1 times D. Likewise, when I add up this, so I get A plus N minus 1D. And last, when I add up with this, what I'll get? A plus N minus 1 times D. Now you can see that, you can see it is thoroughly, all the places you have the same values. Now can you tell me how many terms are all together? Because it is up to the n terms, total number of terms is n, so we have n times this value. Okay, so I'm writing over here twice is equal to n times this. This is a repetitive addition, and repetitive addition means multiplication. So I have taken this term and multiplied by n because altogether they are n terms. Okay, see, I have written. Now I am dividing both the side by 2, so I'll get s equal to n upon 2 into twice A n minus 1 times D. Now you can see we have got the formula s equal to n upon 2 twice A n minus 1 times D. This is the formula what we had to find out. This is the important formula for finding the sum of n terms of an arithmetic progressions. Okay, just see one more thing what I want to share with you all. As I said, nth term is equal to A plus n minus 1D. Okay, this nth term can be also called as last term, and last term means L. Okay, so L is also equal to n minus 1 times D. Okay, both are set. Now what I am going to do over here, just see. Just now we have found out sum of n terms equal. Sum of n terms equal to, it is what? N upon 2 twice A n minus 1 times D. Okay, now what I am going to do, just see what I am going. N upon 2, I am breaking this twice as A plus A plus n minus 1 times D. Now my dear student, you can look over here, from here till here. I will write, in place of this I am going to write L. Okay, so we will get a formula that is n upon 2 A plus L. Okay, even this is a formula to find the sum of n terms of an arithmetic progressions. Okay, now these two formulas, how it works. If we look carefully over here, here we have the first term A, we have common difference D, and number of terms, that is n. We can also write it like this, bache. We can write sum of n terms like this. Further out, we can write it like this. It signifies that sum of n terms. Okay. Over here we have total variables 1, 2, 3. 3 variables. That means the first term you should know. You should know the common difference and you should also know the number of terms. Then you can find the sum of all the terms of the given arithmetic progressions. What about this formula? If we look at it, over here we have A, the first term, L, the last term, and N, the number of terms. That means if you know the first term and if you know the last term, okay, and number of terms, then you can apply this formula to find the sum of all the n terms of the given arithmetic progression.